Welcome students again into the 12th science chemistry class. We are learning the chapter number 1, that is first chapter, solid state. Now today we have to learn the relationship between the molar mass, that is capital M, density of the substance. Density of the substance means density of unit cell. Density of the substance and density of unit cell of that substance is same, and the density of the substance is denoted by the sign rho, and unit cell edge length, that is the side length, edge length of the unit cell. Suppose it is the small a, and it is deduced all these three things, that is the molar mass of the substance, density of the substance or density of the unit cell, and edge length of the unit cell can be deduced by the following steps. Now let us learn first, if edge length of the cubic unit cell. I already told you that in this chapter we have to learn about only the cubic system. There are the three types of the unit cells in the cubic system, that is the face center cubic cell, body centered unit cell, and the simple unit cell. Now if the edge length of the cubic unit cell is A, then the volume is calculated as length into breadth into height. But in cubic unit cell, all these three things, that is the length, height and breadth is A, that is the ledge end. All these three are same, that is the A, that is the edge length, that is length, breadth and height. So volume is nothing but length into breadth into height. So volume of the unit cell V is calculated as A cube. So if we want to calculate the volume of the any cubic unit cell, it may be FCC or BCC or simple cubic cell, then always we have to multiply the edge length 3 times, that is the volume of that unit cell. So A cube is the volume of the unit cell. Now second, we have to calculate, that is the mass of the unit cell. Then how we can calculate the mass of the unit cell? We know that the mass of unit cell is nothing but the how many particles are present in that unit cell, because the mass of the unit cell are nothing but the mass of the particles. We know that in FCC there are the 4 particles. In body centered cubic unit cell there are totally 2 particles. One is at the center, and at the 8 corner there is total 1 particle. And in simple cubic unit cell there is only the 1 particle at the 8 corners. There are 1 divided by 8 part of the particle at the 8 corners. So there is only 1 particle. So the mass of the unit cell is nothing but the how many particles are present in that unit cell. So mass of unit cell is calculated as, if small m is the mass of 1 particle. Suppose the mass of 1 particle is this small m, and if there are n particles per unit cell, then the mass of unit cell is calculated as m into n, that is the mass of the 1 particle into number of particles present into that unit cell. If there are the 4 particles as in FCC, then multiply the mass of the particle by 4. If it is the BCC, then multiply mass of the particle by 2 to calculate the mass of the unit cell. And if it is the simple cubic unit cell, then directly the mass of the unit cell is nothing but the mass of the 1 particle. Now let us calculate again the density of the unit cell. How it is calculated? Let us learn the formula to calculate the density of the unit cell rho. Then I already told you that the density of unit cell is nothing but the density of that substance. So the density of the unit cell, which is the same as the density of the substance, is given by the formula. We know that density is nothing but mass divided by volume. So here density of unit cell is nothing but mass of unit cell divided by volume of unit cell. So density rho of the unit cell is equal to mass of unit cell divided by volume of unit cell. And the mass of unit cell we calculated by m into n. So m into n divided by a cube, because a cube is the volume of the unit cell. So the formula rho is equal to m into n divided by a cube. And this density is nothing but the density of the substance. If in the numericals they ask us to calculate the density of the substance, then we must know that the density of the substance is nothing but the density of the unit cell. So to calculate the density of the substance, we have to calculate the density of unit cell. Rho is equal to m into n divided by a cube. Then the next one is the formula to calculate the molar mass of the substance. It is denoted by capital M. Molar mass of the substance. And molar mass of the substance is given by, that is capital M is equal to mass of one particle into the mass of the particle present in 1 mole. And we know that the particles present in 1 mole is nothing but the Avogadro's number. In 11th standard we learned about that. That is 6.022 into 10 raised to 23 particles are present into the 1 mole of the substance. So mass of one particle into number of particles per mole is nothing but the molar mass of the substance. So molar mass of the substance is mass of one particle into number of particle present into 1 mole of the substance. So m is equal to mass of one particle into number of particle per mole. And number of particle per mole are nothing but the Avogadro's number. So m is equal to mass of one particle means small m. Here is the mass of one particle, we take as the small m, into Na, that is the Avogadro number. And where this Na is nothing but the Avogadro number, and the value of the Avogadro number is 6.022 into 10 raised to 23 particles per mole. So if we substitute the mass of the one particle into this 6.022 into 10 raised to 23, then we can calculate the molar mass of the substance. Now let us learn the relationship between the density of the unit cell and molar mass of the substance. There is also formula for that, and on that formula or on that that is the equation, we have the numericals to calculate the density or edge length or volume of that substance. Pay attention students on a blackboard. Now we already learned these two relationship. Density of the unit cell is equal to mass of the unit cell into, that is mass of unit cell, this, that is mass of particle into number of particle. So density of the unit cell is equal to mass of unit cell divided by volume of unit cell. Suppose it is the equation X. And molar mass of the substance, capital M, we already learned, it is also is equal to, that is mass of one particle into Avogadro's number, that is the particle, number of particle present in 1 mole. So if we have to calculate the mass of one particle, then the molar mass divided by Avogadro number. So mass of one particle is equal to molar mass divided by Avogadro's number, that is 6.022 into 10 raised to 23. So, suppose it is the equation y. Now on combine the equation x and y, we can get here the relationship between the molar mass of the substance and density of the substance. So on combined equation x and y, we get this rho is equal to, now the mass of one particle is calculated as capital M divided by Avogadro's number. That is the molar mass of the substance divided by Avogadro number. So substitute the value of this M in this equation x. Then what is there? Rho is equal to M divided by N. And this N, that is the number of particle here already is that. And this A cube is also there into this formula. So on substituting the value of this mass of one particle of equation y into equation x, we obtain this equation. Density of the unit cell is equal to mass, molar mass of the substance into number of particles present in the unit cell divided by A cube into Na, that is the Avogadro's number, and which is nothing but the density of the unit cell. Now by knowing the any four parameters in this equation, there are the 5 parameters, that is the density of unit cell, number of particles present into the unit cell, molar mass of the substance, volume of the unit cell, and Avogadro's number, that is the number of particles present into 1 mole of the substance, that is 6.022 into 10 raised to 23 particle. If we know any 4 parameters out of these 5 parameters, then we can calculate the 5th parameter. So by knowing any 4 parameters, the value of any 4 parameters of the above equation, we can calculate the 5th parameter. Now let us calculate the 5th parameter in the numericals which they asked us. So we have to solve here now the numerical or problem on this formula. Let us solve that problem. Now let us solve the numericals on the density of unit cell or volume of unit cell or age length. Now here the numerical number 1, that is the problem number 1 is, they ask us to calculate the density of the gold. Now when gold crystallizes, it forms face-centered cubic cells, that is the FCC. That means the unit cells of the gold substance is of the type of face-centered cubic unit cell FCC. Now definitely there are the, how many particles in the one unit cell? 4 particles. We know that. That is the half particle in each face, as there are the 6 faces. So there are totally 3 particles of the faces and totally 1 particle of the 8 corners. So there are the totally 4 particles into the face-centered unit cell. So when gold crystallizes, the problem is that when gold crystallizes, it forms face-centered cubic cell. The unit cell age length is given, that is the A. As that all are the cubic cell, so the age length A is same, that of the length, breadth and height are same, that is the A. So the unit cell age length is given 408 picometer. Now we know that 10 raised to minus 12 meter is equal to 1 picometer, or 1 picometer is equal to 10 raised to minus 12 meter. Then they ask us to calculate the density of the gold, and they also give us the molar mass of the gold is given, and that molar mass of the gold is 197 gram per mole. Now which things are given or which quantities are given? The given quantities are molar mass of the gold, that is 197 gram per mole. Again, as it is face-centered unit cell, so indirectly they given us the number of particles N is equal to 4 atoms of gold, because gold is the, that is element, so there are the atoms in golds, and therefore the face-centered gold unit cell have the 4 gold atoms. So N is equal to 4. Again the formula, in the formula of the density of the unit cell, we know that there is the Avogadro number, because rho is equal to n into m divided by a cube into na. So the Avogadro number, though they are not given, but we know the value of the Avogadro number, that is Na is equal to 6.022 into 10 raised to 23 atoms per mole. Again they given us the edge length. The edge length is given, and that is 408 picometer, that is equal to 408 into 10 raised to minus 12 meter. If we want this edge length in centimeter, then multiply by the 100, because 1 meter is equal to 100 centimeter. Why we take the edge length into the centimeter? Because here the molar mass is given into the gram, that is the CGS unit. So we have to convert this, that is the edge length, which is in picometer, then we convert that into the meter, 408 into 10 raised to minus 12 meter, and that meter is converted into the centimeter. We know that 1 meter is equal to 100 centimeter. So multiply this quantity by 100, and if we multiply by 100, it becomes 408 into 10 raised to minus 10 centimeter, because 100 means 10 raised to 2. So 10 raised to minus 12 into 10 raised to 2, that is equal to 10 raised to 10. Sorry, minus 10. Now here the A is equal to 408 into 10 raised to minus 10 centimeter. Now if we have to give here point after the 4, then again it is multiply by 100, that means 2 points. If we convert here, or if we go here and give the point here, then this 10 raised to minus 10 becomes 10 raised to minus 8. 10 raised to minus 8 is more than 10 raised to minus 10. Remember that. So that means here we again multiply this by 100, and then this point come here. So A is equal to 4.08 into 10 raised to minus 8 centimeter. For our convenience, we do that. If you take this value in this way, that is 408 into 10 raised to minus 12 centimeter, that is also correct. That is not wrong. If you do not give here point, and if you do not convert this into the 10 raised to minus 8, then still it is correct. Now substitute all these quantities in this equation, that is the formula of the unit cell. Now the formula, density of unit cell. So the formula to calculate the density of unit cell is rho is equal to n into m divided by a cube into Na. Here n are the number of particles, m is the molar mass of the substance, a is the edge length, its volume is there, that is cube. And this is the number of particles in 1 mole of the substance, that is the Avogadro number. So on substituting all these quantity, now here see here, out of the 5 quantities, the 4 quantities are given. So we calculate the 5th quantity, that is the density of the unit cell rho. So on substituting the value, n is equal to 4 atoms. Why I write here unit also? Because if we want the density into the unit directly, we can get it directly if we substitute the units also. So 4 atoms into 197, that is 197 gram per mole, that is the molar mass. Now this is the edge length, 4.08 into 10 raised to minus 8. But here is the cube, because it is the volume. So take the cube, and also the centimeter also converted into the cubic centimeter, that is the centimeter cube. And this is the Avogadro number, 6.022 into 10 raised to 23 atoms per mole. In 1 mole there are that. Now here atoms are similar, so they is discard. This per mole also get discard. Now you can solve this problem by using the logarithmic table instead of calculators, because in the examination there is not they not allow the that is the calculator. So you must solve these numericals by using the logarithmic table. And in 11th standard we already done the practice of that of the logarithmic table, how the logs and anti-logs are calculated. Now here you have to first see the log of 4, log of 197, then add their logs. Again you have to see the log of 4.08, and this is 10 raised to minus 24, this becomes and then log of this 6.022, and also add the logs of these two quantity, then subtract the addition of this logarithm from the addition of this logarithm, and then you can see the anti-log. Then the answer will come here. Your answer must come in this way, 19.27, and the unit is, this gram is remaining, and this divided by centimeter cube, so per centimeter cube. So rho, that is the density of the unit cell, is nothing but 19.27 gram per centimeter cube. If we have to convert this in kilogram per meter cube, then we know that 1000 gram is equal to 1 kilogram. So these grams are converted into the kilograms, that is 19.27 into 10 raised to minus 3, because 1000 grams is equal to 1 kilogram. So these grams is equal to how many kilogram? That means we have to divide by 1000, that is 10 raised to minus 3 kilogram. In text there is only 10 raised to 3, but that is printing mistake. So 19.27 into 10 raised to minus 3 kilogram per meter cube is the correct answer. So the density of the gold is equal to 19.27 into 10 raised to minus 3 kilogram per meter cube. So in this way, students, we can calculate the fifth parameter. If they may be asked the Avogadro number or this molar mass or N or A, we can calculate that from this formula. So this is about the density of the unit cell, volume of the unit cell, mass of the unit cell, how many number of particles are present into that, and how the molar mass of the unit cell can be calculated. If you understand very well these, that is the deduction of all these quantities, and also the numericals which is based on this formula of the density of the unit cell very well, then you can subscribe, you can share and like this video, and also you can tell the another students of the 12th science or who wants to give the examination which is based on the national level, such as JEE, CET, which is that is CET is also of the Maharashtra government, and the NEET, which is the national government medical entrance. Then they can also like and subscribe and watch this video. So you can tell the another students to watch, like, subscribe and share this video. Thank you students for watching this video. Now we will meet we will meet tomorrow again by the another topic we can learn into that of the chapter number 1, that is the solid state. Thank you.